Alright, so in this video we're going to talk about compositions of transformations. So on question 2 we have 3 transformations. Let me go ahead and write them out. Okay, so remember when we're looking at compositions of transformations, we have to read them from right to left. So the first thing that we're going to apply is this one on the right side, which is a dilation of a scale factor 0.5. So remember what that means in terms of our little formulas. So all of the points are going to be divided by 2, or you can say multiplied by 1/2 means the same thing. So I'm going to write 0.5 times x, comma 0.5 times y. And that is for this dilation. Once we perform the dilation, we have to perform a reflection across the y-axis. So again, let's try and refresh our memory. What does that mean, or how do we do that? Well, if we have some point here, x, comma y, to reflect it across the y-axis, that means it's going over to this side, which means that the x, we need to flip the sign. So we get negative x, comma y. Alright, and then the third transformation that we need to apply is a reflection over the x-axis. Now that's kind of just the opposite of the reflection over the y-axis. If we want to go over the x-axis, we need to change our y value. So that becomes its opposite sign. So in our formula we write negative y. And then of course for this one, let me just go ahead and write it out just to be systematic. So negative x, comma y. Alright, so these are the formulas that we're going to be using to perform this composition of transformations in question 2. Of course, we need to apply them to 4 points. I'm going to go ahead and draw that on this printed graph paper that I have here. So let me try. Let me see if this works. I'm going to try this out on here. Let's see. This should work out. Okay, so for number 2, our first point is negative 12, comma 6. That would be right here. I'll go ahead and write that. D negative 12, comma 6. Alright, our next point is E, and that's at negative 4, comma 6. So that's 1, 2, 3, 4, 1, 2, 6, that's up here. Alright, and then we have F, which is at negative 6, comma 9, so this is negative 4, so negative 6. Now, I'm going to have to improvise here. We're going to have to go 3 above this. So 4, 5, 6, 7, 8, 9, somewhere right here. Alright, and that one was supposed to represent F. And when you write your answer, make sure that you label your coordinates so the instructor knows what numbers you're placing them at. So that's F. Now we can go ahead and do the last one here, which is G. And that's at negative 10, so it's 2 from here. And at 9, so it's going to be up here. Oh, that's cool, we got like a little trapezoid. Okay. So this is G, negative 10, comma 9. Alright. So these are our points. We get a kind of a cool little trapezoid if you connect them. I'll do that just for fun. Okay. So now we're going to perform our first transformation. Remember, this composition has 3. So our first one was a dilation of 0.5. So again, how do we do that? Well, we need to apply this formula to all of our points. So what I'm going to do is I'm actually going to use the side paper on the side to show the work here. So let's go ahead and do that. So I'm going to, just to organize this, I mean, you don't have to do this, but I actually recommend you do this because it's nice to organize the work so it's not all over the place and confusing. This one was at 9, right? Yeah. And then F was -6, 9. And then E was -4, 6. Okay. So what we're going to do is, for this dilation of a scale factor of 0.5, we're going to go ahead and use our arrow notation. So I'm going to do that here. And then we get D prime is, well, we have to get 0.5 of 12, which is just -6, just half of that. And then half of 6 is 3. Nice. And then let's write G prime. And that one is going to be -5, comma 4.5. Remember, we're just getting half of the numbers, right? Just dividing by 2. And then for F prime, we have -3, comma 4.5. E prime is -2, comma 3. Okay. Alright, so this is for the first transformation. Now I'm going to go ahead and write the second one here. And I'm going to organize it the way I've been doing it here. So this next one is going to be a reflection across the y-axis. Right. So remember, this transformation applies to the output over here. So this is what we call the input, and then this is the output. Remember, this is kind of a side note here. You don't have to know this, but it's kind of fun to know. These transformations are functions. That's important in mathematics in general. Actually, there's a whole branch of mathematics called linear algebra that is the study of this. It's a study of mappings, which are linear transformations from vector spaces to other vector spaces. So it kind of just generalizes this idea. So let's see, transformation, let's see, what was I going to write? Oh yeah, they're functions. More functions. And again, when we see function, we think of inputs and outputs. So we get a point as an input, then we get an output, which is another point, and then this is a mapping of all these different points. So this is just a fun fact on the side. So this is the output of our first transformation. Now that becomes the input for the second one. Remember, this is called a composition of transformations. So here we have G prime -5, comma 4.5, F prime is -3, comma 4.5, E prime is -2, comma 3. Alright, so now to apply this one, remember the formula we're going to be using. I'll go ahead and write it here again. These should be memorized. So for x comma y, what are we going to do? Well, if it's a reflection across the y-axis, we're going to change the sign of the x. So that's what's going to happen. Now here, I'm going to write this as double prime because it's being applied to prime, right? So then it becomes double prime. So D double prime here is going to be what? That's going to be 6, comma 3. Remember, we're only just flipping the x value, the sign of the x value. G double prime gives us 5, comma 4.5. F double prime gives us 3, comma 4.5. And E double prime gives us 2, comma 3. Okay, very nice. So we have just applied the second transformation. Now we can go ahead and apply the third one. Here, let me just adjust this real quick. Refocus, space for that. Okay. This time we're going to reflect about the the x-axis. Alright, and then let me just check something here. Yeah, okay. Just confirming that real quick. Alright, nice. Let's go ahead and do this part. So again, it's a composition of transformations. These are now the inputs, the new inputs. So I'm going to write them over here. So d double prime 6, 3. I know this feels like a lot of writing. That's okay. I'm just doing this just so that it's organized and easy. The information flows easily and the logical ideas flow as well. Just kind of keep it organized. I think you should do this too. Like I said, you don't have to, but I prefer you write it out this way. This is kind of a secure way of making sure you don't make any careless mistakes or anything like that. So let's go ahead and write our arrows, and then now we're going to put the triple prime, because now it's the third transformation. Alright, so remember that if we're reflecting about the x-axis, then that just means that now we flip the y values, the sign of the y value. So now it's x comma negative y. Okay. So for our first point, we get 6 comma negative 3, and then for g triple prime we get 5 comma negative 4.5. For f triple prime we get 3 comma negative 4.5, and then for e triple prime we get 2 comma negative 3. And so this set of points at the very end, once we finish this process, this represents the final image. So what I would recommend is when you're graphing this, you should probably go through each transformation, but definitely, obviously, make sure that you have the final one, right? So I'm just to save time and space here, I'm just going to graph the final one, just so you can kind of see more or less what that might look like. Alright, so let's see. That's 6, negative 3, so that would be on this side. 2, 3, 4, 5, 6. Okay, that's D triple prime. And of course, when you write your answer, make sure that you write it with the coordinates there. 5, negative 4.5. Alright, now this kind of looks like a mess here, but hold on. 1, 2, 3. Negative 4.5, somewhere right here. Okay. And that's F triple prime. And then E triple prime is at 2, negative 3. 1, 2. Like that. Okay, very nice. Alright, so that's how our trapezoid looks at the end. Alright, so I know I'm not supposed to be writing the whole, answer at the very end, but I'm only doing this one of the two problems because I want you to work out the other one independently, and this one should be used for checking, kind of just to make sure that you're doing the work correctly. If you have any questions, of course, you can always ask. But this procedure is going to be pretty much the same for the next one. Where is it? Let's see. Oh my gosh. Oh, there it is. It's going to be pretty much the same. I can go ahead and just explain the transformations just to kind of start you off on that one. So for number 3 we have just so that this makes sense. R. So this is a reflection across the line x equals 1. Put a circle, of course, and then this is a translation to the right 2 units and up 2 units. And then the last one here is a rotation of negative 90 degrees about the origin. So here I'm just explaining what the notation means. Now what I want you to do is go to your phone and check the images. I sent a formula, kind of like a formula chart. It's on a pink post-it note, and that has the formula for a rotation about rotation of 90 degrees. Okay. And then also, of course, a translation means that you're going to shift 2 units to the right and 2 units up. That's what this means. And be very careful with this reflection. So this is a reflection about the line x equals 1. Let me talk about what that looks like. So the line x equals 1 is a vertical line like this. Alright. And to reflect something across that line, I'll make a little example. Let's say you had a point right here, and this point is 2, I'm just going to make it up, 2, 4 or something like that. If you wanted to reflect this point across the line x equals 1, you need to count the spaces between the line and the point horizontally. So how many spaces is it from the line x equals 1 to the point? Well, remember the point right here is at x equals 2, and the line is at x equals 1, so it's basically 1 unit, right, away from the line, which means that you need to go 1 unit to the left of that line. So this would actually end up on the y-axis right here. And so A prime would be 0, 4. Of course, this is just an example to explain what this means, this reflection across the line x equals 1. So be careful with that. We're not using the formulas from the formula chart. Here we just have to count the spaces away from the line and then reflect it to the other side. Alright, so I hope this video was helpful.